to continue to explore using trigonometric ratios to solve problems. We also, I hope that everyone would realize that we have been looking at key basic things that we should know, fundamental things that we should know about triangles, how to label it, how to refer to the length of a side and the size of the angle and so forth. So let us continue. Trigonometric ratios for special angles. All right, so here we have, and we're just going to pretty much go through this quickly because we would have explored some of this in our previous slide. So we have triangle on your left labeled 30, 60, 90 degrees, and you can see the labeling of the sides. Now, from what we would have just explored, you'd realize that your longest side is your hypotenuse, and it is 2 units. 30 would have been your smallest angle, and it is facing your smallest side, which is 1 unit. 60 is your middle angle facing your middle length of side. And of course, some persons might say the square root of 3, what is that? I'd like you to be aware of numbers. The square root of 4 is what, guys? What is the square root of 4?
2.
Good.
2.
All right, good. So the square root of 4 is 2. So therefore, if we're finding the square root of 3, what is the square root of 1? Quickly.
1.
It's
1.
So square root of 1 is 1. So we're not finding square root of 1, we're not finding square root of 4, and the square root of 2 is point something, right?
0.41 something.
All right, there you go. So we should understand that the square root of 3 is going to give us 1 point something. So it's going to be greater than 1 and less than 2. That's all I needed to be able to see. So here we have, we would just put in the sides, and we now know that the sine of 30 is what? So sine 30, you're looking at the opposite over hypotenuse. So if we're looking at angle 30, the opposite is 1 over 2, which gives us 0.5, a half. And you can take a little picture of this because, as I said, we've exhausted this in the last slide. So let's move on, guys. Here we are, using the trig ratios to determine lengths. Continue. We want to determine length AC and length AB without using Pythagoras theorem. So you see what happened there? You're asked not to use Pythagoras theorem. So let's just quickly go through AC. So here we are. What do we know? We know the angle is 30. And we're trying to find the length of the opposite side. So you're given the value of the adjacent side, and you know the opposite side, and you have an angle. What ratio you think is best here? Type in the chat quickly. Or speak freely. So we know the size of an angle and its adjacent side. We need an opposite side. Okay, Jonathan, I see your response. Why would you say sine? I hear the tangent there. All right, so I see a variation of answers coming in. I see sine and tan. Now let us pay attention so we always get the correct ratio. We apply the correct ratio. Sine. Sine is opposite over hypotenuse. Do we have a value for the hypotenuse?
No.
No. So because we don't have a value for it, and that is not the side that we're trying to find out, the sine ratio would not be the most applicable one right here. It would not be, you would not be able to use it to find the opposite on the first go. You could use it to find the hypotenuse measure and then use it again. But if you want to just find the opposite on your first calculation, the sine would not be the most applicable ratio there. So yes, the tangent would be the most applicable because you have opposite and adjacent and you have an angle. So tan speaks to the opposite and adjacent side. Let us do that quickly. So tangent of 30 degrees is equal to the opposite divided, the length of the opposite divided by the length of the adjacent. Great. We can either transpose for AC first, or we can substitute the value for tan 30 and then we work it out. All right, so here we are. We would have transposed AC is equal to 16 multiplied, 16, what unit are we using? 16 meters multiplied by the tangent of angle 30. Let us continue. So we'd find the value for tangent 30 to be 0.5774. That means the length of AC would equal 16 multiplied by tangent 30, 0.5774, which would now equal to 9.24 meters to the second decimal place, because you have to also state what place you would have rounded off your answer to be, so that the examiner knows that you understand that you would have round up or round down. All right, great. Everybody with me? Anyone I need to repeat this for? Type it in the chat or open and speak.
Can you please repeat? Thank you.
Repeat everything.
Yes, please.
All right, so I'm keeping everything on the slide. Let us look. We have a right triangle. You're asked to find length AC. So you're asked to find that side there, which they gave you an angle. So because you know the angle, you would have identified the sides in relation to that angle. So we're at angle 30. The side that they asked for, angle 30 is on your right. The side they asked for is on your left. So we know it is the opposite of angle 30. You with me?
Yes, miss.
The value of the side that touches the angle, that is closest to the angle, is 16 meters. So we know that is the adjacent side. So right away, we have an angle and we know that we have two sides. We have a known side, which is the adjacent, and we have an unknown side, which is the opposite. So we're going to examine our trig ratios. Which of the trig ratio has anything to do with opposite and adjacent? Tell me.
Tan.
Tangent, right. So because we know that the tan of an angle will equal the opposite divided by the adjacent, we can use a tangent, because we would have had two known things out of the three things. Remember, it's the angle, tan of an angle equal the opposite length divided by the adjacent length. So we have two things out of the three. When you have two out of the three, we can always transpose to find the third. Everyone with me?
Yes, miss.
Yes, miss.
So we are going to transpose. We're going to make AC the subject of the formula. When you make something the subject of the formula, it doesn't have to be on the left side. It can be on the right side. So tan 30 equal AC over 16. We are now going to cross multiply, or we're going to multiply throughout by 16 to make AC stand by itself, to make it be the subject of the formula. Why did I multiply by 16? Anyone want to tell me? Although it's not there on the screen, why would I multiply throughout by 16? All right, so when we're balancing our equation, or when we're transposing, we want to undo whatever operation is being done to what we want to make the subject. AC is being divided by 16. AC is being divided by 16. What's the opposite of division, guys?
Multiplication.
Right. So I'm going to do the opposite of dividing, which is multiplying. So I'm multiplying throughout by 16 there. So 16 divided by 16 gives me what on your right-hand side? If I multiply by 16 and then divide by 16, what happens? It does what? Say it, man. It goes back. All right, Shanice. It goes back. I think I know what you're saying. So you are left with AC. Thank you very much, Mr. Garrick.
Because you're really saying 16 divided by 16. When you divide a number by itself, what do you get? You get 1. And 1 times anything gives you what you had.
There you go.
Okay, Shanice? Is that what you mean by go back?
I think that's what she meant.
Okay, good.
All right. So if I multiply tan 30 by 16, I just have to work it out and find the value, correct? So guys, you have to answer quickly. So I know. Yes.
Miss, I'm not sure if you said it already. I was a bit off. Miss, we divided both sides by 16.
Did we divide or did we multiply?
Miss, we multiply because we were dividing.
Yes, we multiplied. Right, because AC is being divided by 16 there. You see the AC being divided by 16?
Yes, Miss.
All right, so I want to get rid of the 16 and make AC the subject of the formula. I want AC to stand on its own. Let's not do it that way. Take it out. Let's do it the other way. So if I'm dividing by 16, what the opposite of division is multiplication. So I'm going to multiply AC divided by 16 by 16. All right, so you see that. Let us do that multiplication. 16, I could have put, right, so 16 to 16 one time, 16 to 16 one time. So it simply means AC multiplied by 1 is, talk to me, guys. AC multiplied by 1 is AC. Everybody's seen that?
Yes.
Yes.
Right. But if I do something to the right side of my equation, what must I do? I must also do it to the good. And that is why you end up with 16 multiplied by tan 30. Are we seeing that? Because I have to also multiply my tan 30 by the same 16. Everybody seen that?
Yes, if my equation is to remain balanced.
Right. So now I end up with 16 multiplied by tan 30 equals AC. That's pretty much it. Another way you could look at it is if you just do a simple cross multiplication, because you can now put tan 30 over 1 and AC times 1 gives me AC, and tan 30 times 16 would give me the value of AC. That's another way to look at it. I don't know which is easiest for you. However, it is the same thing that was being done. It is the balancing, it is transposing for AC and ensuring that what is done to one side of your equation is also done to the next. And pretty much after we have 16 times tan 30 equal AC, we would just work out the calculation. So we'd put in the value for tan 30, multiply it by 16, and it gives you 9.24 meters. Everybody there?
Yes, Miss. Yes, Miss.
All right. Let us move on to the next one. So remember, we're asked to find AC, and now we are asked to find AB. Why did I specify not? Why did I specify not to use Pythagoras theorem? Just quickly tell me.
Is it because the instruction says using trig ratios?
Yes, because the instruction says it. But could you use Pythagoras theorem now?
No.
Hmm?
No.
Why? Yes, Gary, tell us why.
Yes.
Why? Who said yes? I see. Okay, great. I see someone went further to explain. Yes, we can definitely use Pythagoras theorem now because we know two sides. We now know the length of AC to be 9.24 meters. So because we know that, we could apply Pythagoras theorem, but the question specified, do not use Pythagoras theorem. So let us use a trig ratio. So we're asked to find AB. So let us see what we have. We have an angle, and we know that 16 meters is adjacent to that angle. And we're asked to find what side of the triangle. We're asked to find the hypotenuse. So what ratio, which of the three trig ratio, you're going to put it in the chat, will we be using? We have an angle, and we have the adjacent and the hypotenuse. Thank you, Jonathan. Rest of you chime in.
The cosine.
There we go. Yes, Deshaun, and I don't know who just answered. Right, Kalisha, we are using the cosine. Great. So we know the size of an angle and its adjacent side. We need the hypotenuse. Cosine ratio is needed here. Let us do it together. So cosine of an angle, in this case, cosine 30, is equal to the adjacent angle divided by the value of the, did I say the adjacent angle or adjacent side? The adjacent side divided by the length of the hypotenuse. All right, let us work it out. All right, so I know for some persons, let us, can you transpose on the other side for me, please? Giovanni, since we skipped a few steps. So we're going to multiply both sides by AB, or if they want to do cross multiplication. So cos 30 multiplied by AB equal 16 over AB multiplied by AB. You guys see that?
Yes.
So AB into AB one time, so that leaves a 16 on your right side, and you end up with cos 30 multiplied by AB. That's not what we want. We want AB to stand alone. So we are going to do what? What do I need to do to get AB by itself? Tell me before I move to the next step. Anyone? It's in the chat.
What's being done to the AB? Is it something being added to it, multiplied by it? What is happening to the AB? Ask yourself that to know what you should do.
So the aim is when we're balancing, great. When we're balancing, we're undoing what is being done. So as Ms. Harris just said, what is happening to AB? It's being multiplied by cos 30. So the opposite of multiplying by cos 30 is, as Danae said, divide by cos 30. So let us do that. So when we divide by cos 30, you're going to have AB left by itself, and then you're going to have 16 divided by cos 30. Now we can substitute the value of cos 30 and do and actually find out what is the value of AB. Great. So let's do that. So cos 30. What is cos 30, guys? You can try it for yourself to make sure that we're doing the right thing. What is cos 30?
0.866.
Great. Multiply that, divide 16 by 0.866.
Should you get a smaller number or a larger number? These are things you should ask yourself as you do your calculations. If you're getting a number big, you're dividing by a number smaller than 1, you should get a bigger number. So things like that you should ask yourself. Yes, Casey? While we're doing the calculation.
18.47 or 48.
Okay. 0.47 what?
I mean 48. Sorry.
Okay.
What came after
Why
the
did you
7,
change?
Casey?
Why we change? Go ahead, Carol.
What came after
Because
the 7?
there's a 5
Mm.
Okay,
right
so we
after
rounded
7, so I
up.
just rounded it up.
Okay, great. Bear those things in mind, students, because sometimes you may be asked to give your answer correct to a certain number of significant figures or a certain number of decimal places. So you have to remember your rounding rules as you give your answers.
All right. So let's just type Casey. Oh, you just asked the question, Casey. That's from the hand was up. Okay, great. So now let's just tie this up. So we worked out AC to be what? Remind me what we worked out AC to be. Open your mic and talk freely.
18.48.
No, AC, the first side that we worked
Oh.
out.
Sorry.
That's okay. No. Anybody remember what AC was? Yes. Marek says 9.24 meters. Great. And Casey, go ahead. You said the hypotenuse was what?
18.48.
Excellent. Now remember what we said in the previous conversation, that the largest angle is facing the longest side. What is the longest side here? What is the measure of the longest side? Yes, man, you know it, man. Just 18.48 meters. Good. Which is the hypotenuse. And we know it is a hypotenuse. And then the next angle, now I know you guys know this. If we have 30 degrees at B, what is the angle at A? Because you know they're complementary angles. So what's the angle at A?
60.
Yes, thank you, 60 degrees. So that is the middle angle. So therefore it must be attached to the middle length, which is 16 meters. And the smallest angle is 30, which is facing the smallest side, the shortest side, which is 9.24 meters. Everybody realizing all this information that is given?
Yes.
Great. All right, let us move on. All right, using the trig ratios to determine angle measures. Determine the measure of angle B. Let us look at the triangle. All right, so now we are looking at a right triangle. You're given two sides and you need to find the missing angle. What do we do? What ratio are we going to use here? What are the questions that you're going to ask yourself?
Miss, which one unknown?
Okay, so what is unknown here? The angle.
Yes, Miss B.
What two sides do you have? Name the sides that you have. I see you guys have. You have who? No, okay. The hypotenuse and the
Opposite.
and the opposite, because we're looking at angle B. So we have the hypotenuse and the opposite. What ratio uses the hypotenuse and the opposite?
Miss Sine.
Sine. And that's how you determine what you're going to use. Great. So we have the hypotenuse and the opposite. We're going to use sine. So sine of the unknown angle is equal to opposite divided by hypotenuse. and we just substitute those values right in. Everybody's with me?
Yes, Miss.
All right.
Yes, Miss.
All right. So we have the value for the opposite 15 meters, the value for hypotenuse 25 meters, and we want to find the angle B. Let us continue. We can work out the calculation there. So 15 meters divided by 25 meters gives us 0.6. Are we finished? Why? We can't just stop there. Why can't 0.6 work? What was that? Find the inverse to find the angle. All right. If you look at the value of 0.6, it really doesn't look like the value of an angle. How would I get 0.6 there? So
How would I
yes,
get
we
the
are
B?
going. Huh?
No, I'm just saying, how would I get B? I've only found the sign of B and I want to get B.
Right. So we as Dana
Danae
said, we're
said.
gonna Danae, I keep on calling you Dana. As Danae says, we're going to find the inverse to determine what the value of the angle is. So the inverse of, so sine inverse of 0.6 will give us the value, the degree of angle B. So please put that in your calculator now. Learn to use your calculators. So put that in and make sure that we have done the correct calculation. We have put it in correctly. So if you check your calculator, it should be a second function. So it's 0.6 and your answer should be, just tell me in the chat. What did you get for the inverse? Okay, I see 36.87, 36.86. Why is 36.86 almost right? Make sure you round off properly, everyone. There is a 9 that follows that 6, Kalisha. So we must round up. Great. Thank you very much, Miss. All right, awesome. So are we any better at looking at the use of trig ratios and when and how to apply them? Type in the chat yes or no. Are we any clearer? Are we seeing how we use a ratio, identify the ratio? Great. Let us move on to the next slide. All right.
Kenosha, what you're not clear on? Quickly, Kenosha, you said not really. What you're not clear on, Kenosha?
Oh,
Kenosha, you able to type or say what you're not clear on? Will another example help? Because maybe as we do the examples, we will. Okay, Kenosha, you're gone quiet on us. You said not really.
all right. We're just going to,
Okay. When to use sine or cos. So remember
right.
our soccer tour. So you look for what you know. So if you notice the last example that Mrs. Fenton did, in this example, we know we need to find, we know the opposite side that is opposite to the angle, and we know the side that is at high, we know the length of the opposite side, and we know the length of the hypotenuse. All right. So if I know opposite and hypotenuse, I ask myself, which of the trig ratios has the opposite and hypotenuse? My little thing to remember is so, ka, to, wa. So, sine is equal to opposite over hypotenuse. That's the ratio that has opposite and hypotenuse. So I'm going to use my so. If I were given BC, which is adjacent to the angle, so for example, if that BC were, for example, 13 centimeters, then I would use so ka to wa. So it would be adjacent over hypotenuse. So you look for what you know and what you need. Well, I should just say, look for what you know. If you look for what you know and what you need, you will know what to find. Does that help, Kenosha? So I use sine if I have been given opposite and hypotenuse, or if I have been given angle and hypotenuse and I need an opposite. So it looks at what you look for, what you know and need, and what is in the ratio. Good. You said okay, thanks. You're welcome. I hope that made it clear.
Yeah, Kenosha, we're going to look at some more. I'll call back we'll bring up some other things as we progress, and I hope that clarity will come. All right, let's move to the next. Let's move on. All right, so would trigonometrical concepts apply here? What if a restaurant needed to build a wheelchair ramp for its customers? Do you think trig could work here? All right, so someone is asking how we use cos and tan and sine on the calculator. Let's just quickly do that. Can you bring up a scientific calculator, Mr. Lime?
Bring up a scientific calculator?
Yes, please.
Okay, let me try.
So while Sir looks for that, Roxanne, you have to look familiar with your calculator. So some calculators we call the angle, the argument. Some of them you put in the angle before the function. Some of them you put the function before the angle. So if I, for example, want to find, Sir is looking for the calculator. So while he's saying it, so if I want to find, for example, the sine of 30 degrees, or let's say the sine of 57 degrees, I'd have to put in for some calculator. That's why you must know your own. For heaven's sake, please know the calculator you're going into the exam with. Because if you don't know the calculator, you're going to make an error. So
yes,
let's have a calculator. I do have a scientific calculator with me here. So
I'm
Mrs.
trying. Okay,
So
so you can see my calculator. Now, my calculator may not work as yours. So as Ms. Harris was emphasizing, you have to get accustomed to your calculator. Now, let me take off this. So my calculator requires me to put in the sine first. So I have to press sine, and then I put the angle in. When I press sine, I can't do both of them, you know. So for instance, I have sine here. Let's see. So sine, mine have a display. So if you can see, Carol, can you see my screen, my calculator?
Let me make my screen bigger.
The screen is up. I would want to, if you want to use my screen.
Yes,
go ahead, sir. Yes.
Go ahead.
Just tell me what to input, please.
All right. I will definitely do that.
So let's try sine of 57.
I'm not seeing it though, but.
You're not seeing my screen?
Not yet. We're still seeing the slide.
Seeing the presentation still. There you go. Thank you. So most of the calculator that has a display, it requires you to put in the sine first. Hold on. Yes.
Did anybody see what happened to Sir a while ago? It was not in degrees, and so you got a negative answer.
Exactly.
You have to make sure that it is in degrees.
Can we increase the screen, the size of your screen? There you go. Perfect.
Thank you, Sir Lima. Beautiful.
Thank you. All right, guys. So let's let's remove everything. Press
You're looking, Roxanne?
Clear. Let's clear that.
Well, it is clear. You can continue.
See, okay, great. Okay. All right. So guys, so when you're working with your sine and cos, for this here, some of you use your phone a lot. It's not very wise because you can't take your smartphones into the exam. But if you are using it, some phones, when you hold it in a, what you call
landscape.
A landscape,
you get scientific.
It becomes scientific. When you hold it in the portrait, that is your regular phone, top to bottom, it is a adding machine, right? So it doesn't have the scientific function. But here we are. This is as good as it gets right now. So we want to find what is the value for sine 30 degrees.
No, don't use a 30. Let's use another angle.
Okay, we know let's use 25. It's true, because I know what it is. So 25, I would want to put in 25 first. So 25 sine equals, so it tells me that this particular calculator requires me to put the sine first, because when I put in 20, The angle first, sorry, thank you. The angle first. No, the sine first. I have to
No.
put sine before I put the angle in, before I put the value of the angle.
All right, sorry, that's right.
Yes, because if I put in the angle first and then press sine, I get an error. So that tells me that I need to re-enter the data, the information. So let's clear that. And from my experience, most of the calculators that gives you a screen, a display, so it tells its sign appears on your screen, requires it to come first. So now I'm going to find the sine of a given angle. 25 equal, there, that's the angle. So as you can see, that small type up top tells me that the sine of angle 25 is equal to 0.4226, and it continues. If I round it off to 3 decimal place, it will be 0.423. If I round it off to 2 decimal places, it will be 0.42. Do we understand? Roxana? And now let's try cos. So once you have to put in the sign first, the same thing for cos and degree. Now, what about the inverse? So let us look at the inverse here. Now, if you look on the things that are here, you realize that you don't see the inverse. So you still have to know your calculator. So INV there gives me the inverse. So you see what happens? Go back again. Go back to the sign. All right, go again. So several things, it gives me the inverse, not only of your sine and your cos, but other things on the screen as well. Go ahead. So let us go to the inverse of sine. So one of the known thing, okay.
All right,
All
let's
right.
you know, in hindsight, maybe we should use the ones that we've gotten familiar with. So we could probably use the accent of 0.866 and see what we get.
So let us look at 0.866. We would have worked this out already to be angle what? Remember when we did angle 60, would have gotten 0.866 something. Because we rounded it off to 0.866 and not 0.87, or not give the entire value, it would have given us a figure that is closest to. If we round off 59.997, we would have gotten 60 degrees. And that is why we were saying to you, it's important not to round off incorrectly or round off too quickly. All right?
Are you
Roxana
better now, Roxanne? Type in the chat if you can't talk. If you can't open your mic. Are you better now? Miss V. Norman Manley. Hi, Roxanne. Let's hear from you.
So the key is wherever she is. Okay, Miss, okay. We still don't hear from her. But the key is, and this is very important for everyone, scientific calculator inverse
Yes, Zoe. For some, instead of inverse, you might see shift, or you might see second function.
Yes. So the key point to take away from this, you have to familiarize yourself with your calculators. Know how it works, know how it functions. All right. So let's just get back to the presentation. We are going to end shortly for your lunch break. And then we will come back. So here we go, continue, go through. I'm just going to go through these. So here's your RAM. And yes, we can definitely use trig ratio. Let us look at how we would form that. Once you know what angle the RAM should be placed at, those are key points. You can now decide the distance that you will start the RAM from. And this is also used when you're making staircases. So these are actual ways in which trigonometry is, the trigonometrical ratios are being applied to construction. Okay, go ahead. All right. So both trig ratios and Pythagoras theorem can be applied here or are applied here to get a ramp at a particular angle. And you guys should know that putting a ramp for a restaurant must be at a particular angle because you don't want it too slope for the persons to be struggling to get up the ramp. And of course, there is definitely a height that you need to reach in order to get into the restaurant. So these are very important things that we need to note. All right. In a football match, a player is called to take up a penalty kick. Now, we just finished World Cup, and you realize how many persons would have gotten the penalty right and gotten it wrong as well. So although they may not do the actual calculation, in their head, they are working on what is the best angle to kick this ball at, so not to pass the bar or to go into the hand of the keeper, right? Or to even hit on the bar, because sometimes he's on the bar, it may not make it. So that's trig at work again. All right. So there we are. We are still applying trigonometrical concepts right here. Let's continue. All right, an airplane is 4. So this is an actual question, and we're just gonna walk through it. So an airplane is 400 kilometers from its point of takeoff and 300 kilometers above the ground. This is a very unique plane.
Yeah,
What is the size of the
we're just
angle?
using numbers here for the practice. It's not as realistic as we'd like. So no plane goes as that high, but that's all right. We're just using it for the numbers.
Probably
Just
a rocket, people.
for record.
All right. So what is the size of the angle formed between the airplane and the ground? We're not going to do any true calculation. I want you to tell me what ratio would you use here? Just quickly tell me, type in the chat, what ratio would you use here to find the missing angle?
Miss Miss.
Okay, so you're using the tan ratio. All right, great. That's what I want you to be able to do. I want you to be able to see that you're given the angle, the side facing the angle, which is known, is the opposite, and it is also the adjacent is right here. So you have the adjacent and the opposite, and you want to find that angle. So therefore, you are going to use your tangent ratio. We also want to know that that is your angle of elevation, because you'd have been on the ground and the plane would have been in the sky. All right, so it would be at an elevated distance away from you. All right, great.
The takeoff angle for the plane. It's really the angle of takeoff.
All right, makes sense. So we're just going to go through the inverse of the trigonometric ratios. All right, so if we have any angle, in this instance, we're going to say tan x is equal to the opposite length divided by the adjacent length. In order to, whenever you are trying to calculate the value of the angle, it is the inverse of the rate of the function multiplied, or no, sorry, my bad. It is the inverse of the function of the ratio that exists. Or here they have the argument that will give you the value of the missing angle, or the angle that you're trying to find out. Carol, you want to chime in there? Are we good?
Meaning the argument, I'm sorry. So basically the argument is the ratio that the ratio that you're going to use. And it's telling you the value that I have, what angle will have that ratio. It could be any two lengths, but those two lengths will give me a ratio that's going to give me that angle.
The inverse of that ratio will give me the value of the angle. All right, continue.
And I should just quickly say that the inverse is really asking you, what is the angle that has this value for tan? Which angle has this value for tan? What's the size of the angle that has this value for tan? It doesn't matter what two numbers I'm dividing, but this is what it works out as. This is the ratio it comes on to. So yeah, so that ratio is called the argument. And we are going to use that argument to get the angle. All right, we can probably go through this quickly, because not as, yeah.
All right. So as you can see, the inverse of sine x, inverse of cos x, inverse or tan x inverse, whichever way you want to say, is an argument and should not be separated when calculating an angle. All right. And you can see how you represent the inverse by the sine, cos, or tan raised to a -1. When the inverse of a trigonometric function is found, it means that we are finding the measure of the angle which resulted in the corresponding values. So we now know that cos 30 gives you what? 0.5. Sine 30, sine 30 gives you 0.5, half. So it is the inverse. Am I correct, Carol? So it is the inverse sine 30.
So tan inverse of a sine inverse of a half will be 30 degrees.
There you go.
So sine inverse of a half will be 30 degrees. In other words, the angle with a sine of 0.5 is 30 degrees.
Okay. And that's
Is
pretty
everybody
much
clear on that? So
Yes,
the
ma'am.
argument is the value, the number that you're going to use to find the inverse sine.
So let's just say it again and then we wrap up, and
So
that's it.
tan inverse one would be what? What number? Don't write it yet, sir. Can anybody type in the chat? What angle has a tan of 1? That's what that is saying. What angle has a tan of 1 based on what we did earlier on? Great, 45 degrees. Way to go.
Right.
Got that.
So the inverse of 1 would give us our 45. Great. All right. Let us continue. All right, so here we are. We are now, so before we even go into this, so far, we've been looking at trig ratios. We also did a little review on Pythagoras theorem, and trig ratios exist. We have 3 ratios that you'll be using at this stage: sine, cosine, and tangent. We have an acronym that helps us to remember the lengths of the side, the lengths of the side that are found in each ratio. So we know that sine of an angle is equal to the opposite over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse. And tan, which is TOA, T-O-A, TOA, which is the tangent of a known angle, is equal to the opposite over the adjacent. Those are things that we would have covered. You can use these ratios to find a missing side if you are given an angle and a side, or you can use these ratios to find a missing angle if you are given the 2 sides. Did I say it all? All right, I think I did.
Generally,
all right, so here,
we left out anything there, yeah.
All right, so here we are now looking at this dog. Let's see what this dog is up to. Go ahead. So the dog is moving his head up. And when he does, he is, so originally, if he was just walking on the road and his face was placed, or he was looking in front of him, you know, we call that our eye level. We're not looking up or down, that's our eye level. He now look up, an angle of elevation is formed. Continue. Bird is up in the tree. And if the bird is just looking outside, looking out at eye level, the bird is now looking down. An angle of depression is formed. Let us continue. So, angle of elevation is the angle between the horizontal and the line of sight. The line of sight is also, the line of sight is where you're looking. The horizontal can also be seen as your eye level, okay? So let's look at that again. The angle of elevation is the angle between the horizontal or the eye level and the line of sight to an object above the horizontal. All right, let's continue. We'll look at it more. The angle of depression is the angle between the horizontal and the line of sight to an object beneath the horizontal. So when you are looking at something above your eye level, you get a Angle of elevation, when you're looking at something below your eye level, you get an angle of depression. Not necessarily your line of vision, but whomever or whatever point of viewing we're looking at. All right, let us continue. So here we are now, we have a compound diagram. So we have this diagram where you have the dog is looking at the bird. So that line of sight would be from the dog to the bird. And that is your inclined, you can also label it inclined line of sight. And you have the horizontal, which is the same as the eye level, and an angle of elevation is formed. Now we're focusing on the bird. The horizontal or the eye level is that, what you call that? Horizontal line, yes. And when the bird looks down on the dog, the line of sight is to the dog, and you have an angle of depression formed. All right. All right, guys. We are going to stop shortly after this. Let's see what, okay, we're going to break here, guys. We're going to take a break and we are going to come back at, it's now 12. We come back at 1 o'clock. All right?
Yes.
Yes, Miss.
Yes.
All right. We're
And
going
check
to do,
the
we're going to
list.
put an evaluation in the chat. And you are just going to fill out an evaluation form for us.